So today we will continue with the same topic, current in electricity. So today we'll discuss how does the current flows in a conductor. So for that, the question is, how does the current flows in a conductor? Okay, to understand this, let's have a diagram here. Suppose there is a conductor. There are number of electrons like this. So many electrons. Each electron in the outermost shell, say I could say these are the number of atoms I found in a conductor. Each atom has some free electrons because electrons are in the outermost shell. So each electron, if I consider this is one of the electron, they are free to move in any direction. Maybe this one is going that way, this is one electron. There are number of electrons in this. This is going in this direction, this is going in this direction, haphazard way. There is no fixed because they are free to move. So this is another direction, this is another direction like this, you can see. So if you can arrange these elements or these electrons in a straight alignment order, then the current will start flowing. Straight alignment order means every electron has to be in one direction like this. This is called straight alignment order, means one direction. There are so many directions here. So they are repelling each other. One is going this way, one is going this way, one is going that way, like that. So if you can arrange these electrons in this direction, then the current will start flowing. Or electron moves means current will start flowing. So to do that, what we do is we connect it to a cell. This is suppose one cell I have collected here with the symbol of cell. All the symbols I will discuss today. Suppose I have connected here. The longer line is positive, shorter line is negative terminal. That means if you see a cell here, on the cell you can see there is a cap, that is positive terminal, this is negative terminal. So what you see, that means it has some potential, it has potential energy which you are discussing in the last class. The potential energy when it is given means some energy or some force is given to this. When you give the force to this, what you find? Now you find a new direction. So instead I should draw this, I should do another diagram for this. So when the conductor is not connected to a circuit, the elements and the electrons are in the haphazard manner. So if I connect this conductor to a cell, okay, this is your positive, then this is your positive direction, this is your negative direction, this is positive, this is negative. These electrons first will be in the straight alignment order, not haphazard. Okay, then they will be in this direction. So when you give some potential energy from the cell, then getting that energy they will be in unidirection. Then negative electrons are negative charge, they will move towards the positive side cell of the positive side of the conductor which is connected to the cell. That means electrons will start moving this way. Then it will go inside the cell. This is the direction of movement of electrons. Got my point? So once the electrons completes the circuit, a potential difference is created, then the current starts flowing in the opposite direction, that is positive to negative. The current flows from positive to negative. You can see there. So how it is, I will explain you. First let me tell you why. How does the current flow? We will explain this one. You can write out the answer of this. The free electrons in a conductor move randomly. Okay, so when the conductor is connected to a cell. Cell means one battery. Cells, so many cells will be called as battery. So this is your cell, one is cell. Okay, but if you connect like this, one cell, then another cell, then like this. So there are two cells here. These two combinations will be called as battery. This is cell. This is battery. Number of cells will be called battery and one will be called as cell. So what I have done is I have given to a suppose a 6 volt cell. Suppose 6 volt. It could be 1.5 volt also. It could be 3 volt also. So you can see in that cell it is written 1.5 volt. Means the potential difference is 1.5. You can see the cell is 6 volt. That means potential difference between 2 and is 6 volt. Volt is a unit of potential difference. That means in one end there is shortage of electrons, other end there are excess of electrons. Okay, anyhow, that we will discuss later on. Come to this point. When this conductor is connected to a cell through a wire, what means there? The potential energy PE, potential energy, or I can write here potential energy of the cell. What it does? Arranges the free electrons in the straight alignment order. This is called straight alignment order, and the free electrons move towards the positive side of the conductor. What does it mean? Because this wire is connected to this cell, because one wire you are connecting here, another wire you are connecting here. This is positive side of the cell, this is negative side of the cell. So electrons move from towards the positive side, and it completes the current. Okay, that means it completes the circuit. And completes the circuit when the current flows. Complete the circle means they move like this. Okay, now this is a question. Now the question was why the electrons move from negative terminal to positive terminal, but conventional current flows from positive terminal to negative terminal. Okay. Question is, why does the conventional current flows from positive terminal to negative terminal of the cell through the conductor? Means what I want to say here is electrons flow from negative to positive. It goes like that. Current flows from positive to negative. So this is positive, this is negative. Then this is negative side is connected here. Current flows in this direction, electrons flow in this direction. So short answer I can tell you. The diagram will help us to know. To understand that, take a piece of conductor, connect it to a wire, connected to cell. This is negative, this is positive. Okay, let me consider 4 electrons. So when potential is supplied to this, so when potential is supplied to this means the energy is given to these electrons, they start moving from negative to positive direction. This already I have told you. Suppose this is one atom, one electron move out. Suppose one electron move out. If one electron moves out, then I told you before atom is neutral. Suppose atom is neutral. There are suppose 10 protons here. Then there will be 10 electrons like this. But my point, if one electron is moved out, then how many electrons are there? 9 electrons. 9 electrons will neutralize 9 protons because they are equally in magnitude opposite charge. So 9 electrons will neutralize 9 protons. That means one excess of proton will be in this atom. That means when this electron moves out, this atom is positively charged. Why positively charged? Because if one electron goes out, there will be a shortage of electron, means surplus of proton. So that atom is positively charged. So when this is positively charged, again this will attract its free electron. Because there is again shortage, because one is gone. So when there is empty place, this will attract another electron here. Got my point? So when again this is leaving one electron, again this is positively charged. Again this is positively charged, this will attract another electron here. So again shortage of electron, positive charge. Again this will attract electron, this will be positively charged. Look at my question here. Electrons moving this one. This is the direction of electrons. So when the electrons move like this, they leave each atom in the opposite direction of positive charge. Look at here. This is gone, this is positive. 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 That means in which direction our positive charge is moving? in the opposite direction to electrons. So electrons move from negative to positive. Conventional current moves from positive to negative. So that is the reason why conventional currents are in the direction of positive to negative. That means ulta direction में हो रहा है. This direction conventional current. This direction electron current. Electron current moves from negative to positive. Conventional current moves from positive to negative. So you can write 2-3 lines on this. What are you going to write? You can write 2-3 lines here. When a conductor is connected to a cell, the electrons in the conductor are in the straight alignment order electrons are in the straight alignment order and they start moving in the direction negative to positive. At the same time, each atom in the conductor, losing electrons become positively charged and the atoms show the direction positive atoms. Positively charged atom shows the direction opposite to the direction of the movement of electrons. Hence, the conventional current is in the direction positive to negative. Okay, this is what. Then I'll talk about potential and potential difference. define potential and potential difference. Okay. Electric potential. Potential means electric potential. Suppose there is an object here which you are charging. Any object, suppose you are giving a charge. How you are giving a charge? Suppose I have connected this to a cell. Suppose I am giving positive charge to this object. Could be anything, metal or a conductor, whatever it may be. So what will happen is, when this positive charge is fully charged, when this is positively charged, now what I will do is, I will put a small positive charge, 1 coulomb suppose. Suppose I will bring 1 coulomb of positive charge towards this. What will happen here? Now this is positively charged, object is positively charged. So like charge will repel each other, that will still go to somewhere, some unknown distance. Suppose this electron has reached to this point. So when it is repulsing, suppose this is reached here. Point we don't know where it is. Now if you want to bring back this one to this place, you have to do some work. You would give some energy to this, then only it will come. Now otherwise it is getting repulsed, because this is a small test positive charge, this is a big charge which is repulsing it, because this is positively charged, this is also positive test charge of 1 coulomb. So it is repulsing means it is pushing that side. When it is pushing that side, you have to bring it back. How to bring? Now you have to do some work. So when you displace it, apply some force. If you apply a force, then only it will move. So force is given, distance is covered. So force into distance is called work. So when you apply some force or energy given to this, it moves from unknown place to this place. That is called infinite to this point. So amount of work done to bring a unit positive charge from infinite to the required point is called energy required. That energy is called electric potential. So you can write the amount of work done to bring a unit positive, class B, positive test charge from infinite to its own place. Is called electric potential. EP, electric potential. So what are you doing? You are doing some work. How you are doing? Now you are giving some energy to this. Energy means energy is stored in the form of volt. The potential you are giving, potential energy is given to that. So you can write work done equals to V by Q. Why V by Q? You are doing some work. Potential is defined. How you are defining potential? You are doing some work. How you are doing a work? You are bringing a charge. So bringing a charge means you are doing the work over the charge. So V equals to W by Q. Okay. Now, if I write the SI unit, the SI unit will be V वोल्ट का पोटेंशियल, V का 1 इंच का वोल्ट, वर्क का जूल, दैट इज J, Q का चार्ज, charge means that is coulomb, C. So 1 volt equals to 1 joule by 1 C. So how will you define 1 volt then? How are you going to define 1 volt? Define 1 volt. That is the amount of or 1 joule of work done to move a test positive charge of 1 coulomb from the amount 1 joule of work is done to move a test positive charge of 1 coulomb requires a potential of 1 volt. Okay, that is potential means the energy at a point in a conductor. This is a conductor. Suppose at this point what energy you have, that is your energy at a point, that is potential at that point. Potential in the other sense is what? Energy. Means you are giving some energy to do some work. Okay, now what is potential difference? Potential difference, that is called PD, potential difference. So what you are doing in potential, you are doing the work to bring a test positive charge of 1 coulomb from infinity to this point. But here you are doing a work to bring the same charge of 1 coulomb from one point to other point. That is called potential difference. Doing the same thing, here the last point is not fixed, here the last point is fixed. So that makes a potential difference. That means potential difference between A and B means you are doing some work to bring that charge from B point to A point. That is called potential difference. You can write down the amount of work done to move a test positive charge of 1 coulomb from the point B to A. More again in details you will study in the higher class. Only thing you remember, you bring a charge from B point to A point, you need some potential means energy. That is the potential difference between these 2 points. So you can write VAB here. VAB means potential difference between A and B. The formula is same, which you can write is also V, which is equal to work done by charge. Work done by charge. This is the now study today some instruments like instruments used to measure the first one is current. Which instrument is used to measure the current? That is A. A means ammeter. Okay? Ammeter is an instrument which is used to measure the current. Second, potential difference. Potential difference used by an instrument symbolized as V, that is voltmeter. Okay, measuring a current, detecting a current is different. Suppose there is a wire. If I put the voltmeter here, I can say what is the potential difference between these points. I can change just after putting this. If I want to know, detail I will tell you about this. If I want to know what is the potential difference between these two, what is the energy between these two now, then I can use this voltmeter to measure it. But if I say whether the current is flowing or not, not measuring current, but there is current flowing or not, then the instrument used is called galvanometer. That means when you enter to your physics lab, you will see all this, how is ammeter, how is voltmeter, how is galvanometer. This unless you see it practically, you cannot understand. When you go to your physics lab, you will understand all these things. But anyhow, you should know what is called a galvanometer. G. Instrument used to measure, detect the current. To detect the current, that is G, means galvanometer. Okay. So when you connect it to measure this, how is this ammeter connected, how this potential voltmeter is connected, that also you should see here. How are the following instruments, these are all short questions, used to measure used in the circuit, that is better, used in the circuit. Let me tell you, suppose there is a conductor here. This is a conductor, suppose. Connected to say smaller line negative, this is positive. Suppose I want to know whether the current I is following or not, because I has to follow from positive to negative. How to know this current is flowing or not? Not detecting, measuring the current, how much current is produced. That means look at here, there is a piece of wire. With this, if you add series, this is same line. If between 2 years, if you are using this instrument, that is called series. They are in the same way. So that will be, suppose that means you are putting here an ammeter. So that is your called series connection. Sometimes you may be asked to draw a diagram to show the instrument used to measure the current. This is diagram you can write to measure the current. Ammeter is connected in series. Then what is the other one? Parallel. How it is used? Look at here. To measure the potential difference between any 2 points in the conductor. The voltmeter is used in parallel or is connected in parallel. Okay. So what is parallel you understand? Suppose there is a piece of wire. Okay. Then if you go straight, that is series. But if you make a junction here, it's like this. This is called parallel connection. That means this is piece of wire. Another piece of wire you are joining, that is series joining. But if you make a junction, you do like this, then it is, or you can do like this, joining here. This is also because you create a junction here. That is called one wire going like this, other wire going like this. This is called parallel connection. So parallel connection means this wire I connect to cell. Now I want to find what is the potential difference between A and B. Then whether that voltmeter I will use here or I use here, then I will connect another piece of wire, then I will put it here. This is B. So this is, and combine if you want to put ammeter and voltmeter, then ammeter has to be put here. That is called series. This is your ammeter. Okay, but voltmeter will be this wire and this wire should have a junction. What is the meaning of junction? There is one piece of wire. Then you bind another wire and take it this direction. That is called parallel connection. This is called parallel connection. The straight is called series connection. We are talking about this one only. We are talking about voltmeter. So ammeter means I can put it somewhere here on the same piece of wire. I can put anywhere. I can put it here, I can put it here, I can put it here. But it should be same piece of wire. That is called series. When two pieces of wire means you create a junction, then it is called parallel connection. So this wire connected to voltmeter, another piece of wire is connected. This is different piece of wire. This is called parallel connection. Similarly, third one, galvanometer. Very simple. Same I am writing here. Galvanometer is used in series. Third point. Just it has to detect the current. So look at here. I draw a diagram. Look at this circuit. One piece of wire is coming, Siddha. So galvanometer in series. Ammeter is same piece of wire. Then this is ammeter. Short question will come. So whether the diagram is correct or not, you have to check. If there is another piece of wire going from junction, then that voltmeter has to be connected. The same piece of wire is going, the ammeter is connected. The one piece of wire you have joined and joined here. So ammeter, galvanometer in series, because that is in the same piece of wire, voltmeter in parallel. Okay. So next class we will study some other topic and also Ohm's law.